Hi everyone. In this video I am going to do real numbers connective questions. Real numbers related connective questions. So connective questions are two types. Concept to concept connection and next chapter to chapter connection. Concept to concept connection and chapter to chapter connection. So first question. If a is equal to root 243 by root 3, then find the value of log a to the base 3. Log a to the base 3. Solution. Everything you can note down. So what is given? A is equal to root 243. Root 243 can be written as root 81 into 3 by root 3. Root a into root b can be written as root of a into b can be written as root a into root b. So root 81 becomes 9 into root 3 by root 3. Root 3 gets cancelled and 9 is the answer. If 9 is the answer as a value, therefore log a to the base 3 is equal to log 9 to the base 3. And 9 can be written as log 3 square to the base 3. And this can be written as 2 log 3 to the base 3 is equal to 2. 2 log 3 to the base 3 is 2. Because log 3 to the base 3 is 1. Log a to the base a is 1. Formulas you have to know, you have to apply and you have to write in the side. Log a to the base a1, here log a to the power of m is equal to m log a. So those are all you have to write compulsory. So this is the first sum, first connective. This is chapter to chapter connective. Concept to concept connection. Next. Note down along with me. I won't give them much time. Next, second question. Find the value of log of cosecant 45 degrees to the base 2. Cosecant 45 to the base 45 degrees to the base 2. This is a connective question to the first chapter to the trigonometry. And as you know that cosecant 45 is root 2, then it becomes log root 2 to the base 2. And that can be written as log 2 to the power of 1 by 2 to the base 2. Again the same logarithm formula, log a to the power of m is equal to m log a. So 1 by 2 log 2 to the base 2 and its answer becomes 1 by 2. Its answer becomes 1 by 2. So logarithm of cosecant 45 degrees, cosecant 45 is root 2, then you will get log root 2 to the base 2 is 1 by 2. Next. This is the connective question between logarithms and that means first chapter to trigonometry, 11th chapter. Next, third question. If log 2, comma, log 4 and log x are in arithmetic progression AP, 6th chapter connective question, find x. So let us assume that log a is 2a, log 2 is a, log 4 is b, log x is c. Then any three numbers, if any three numbers consecutive numbers are in AP, then what you will get? If a comma b comma c are in AP, implies b is equal to a plus c by 2. b is equal to a plus c by 2. So if three consecutive terms ABC or three consecutive terms of AB, then B is equal to A plus C by 2 you will get. So what is B here? Log 4 is equal to A plus C is log 2 plus log x by log x by 2. Then 2 transpose this side. 2 log 4 is equal to log A plus log B becomes log AB 2x. And what is the formula for 2 log m log A? Log A to the power of m. So log 4 square is equal to log 2x you will get. And single logarithms are there, we can cancel the log. So x is equal 2x is equal to 4 square is 16 and implies x is equal to 16 by 2 is 8. So what is the x value? 8 is the x value. X value is 8. So this is the connection between 6th chapter progressions to the first chapter real numbers. Next, one more beautiful question. Fourth question is, if log of a plus b to the base 2 is equal to 4 and log of a minus b to the base 100 is equal to 1 by 2, then find the value of log of ab to the base 39. Log of ab to the base 39. See, solution, you can write it as two conditions are given. If means given condition. If two conditions are given, you have to observe that. What is the first condition? Log ab to the base 2 is equal to 4. So from this, the law is log n to the base a is equal to x if and only if a to the power of x is equal to n. In logarithms we learn this law, this definition. So according to that definition, what you will get? A plus b is equal to 2 to the power of 4 implies a plus b is equal to 16. This is the first equation. And secondly, you will get here log a minus b to the base 100 is equal to 1 by 2. So a minus b is equal to 100 to the power of 1 by 2. So root to the power of 1 by 2 means root. So a minus b is equal to root 100. That is nothing but 10. That is nothing but 10. So two equations you got. From those two equations we will solve. A plus b is equal to 16. A minus b is equal to 10. So 2 plus b minus b gets cancelled. 2a is equal to 26. So a is equal to 13. And a is equal to 13. A plus b is equal to 16 implies b is equal to 16 minus 13 is 3. Is 3. So a is 13. B is 3. Then what he asked? Log of AB to the base 39. What is log AB? A is 13, B is 3, 13 3s are 39 to the base 39 becomes 1. So what is its value? 1. Okay. So this is the connective question with the fourth chapter. That means elimination method. Here we applied the elimination method. A plus b is equal to 16, a minus b is equal to 10, cancelling b elements, 2 plus b and minus b. So that is the elimination method, connective with the fourth chapter. This is the connection with the fourth chapter, real numbers and fourth chapter. Next. Fifth. If A comma B comma C are in geometric progression, GP, geometric progression, then show that log A to the base 10, log B to the base 10 and log C to the base 10 are in AP, or in AP. Solution. If ABC are in GP, given condition we have to consider, or in GP. GP means geometric progression, implies B square is equal to AC, you will get. B square is equal to AC. So apply log to the base 10 on both sides. On both sides. Then what you will get? Log B square is equal to log AC to the base 10. So here log A power m is equal to m log A. 2 log B to the base 10 is equal to RHS is log AB formula, log A plus log B. So log A to the base 10 plus log C to the base 10 and transpose 2 to the RHS so that you will get log B to the base 10 is equal to log A to the base 10 plus log C to the base 10 by 2. If B is equal to A plus C by 2, then automatically what things are in AP? ABC implies you will get ABC or in AP. ABC or in AP. Or in AP. Arithmetic progression. A means what? We assumed as A is log A to the base 10 and log B to the base 10 and log C to the base 10 are also in AP. Arithmetic progression. What he asked you to prove is the same. Understand? So this is also connective question with the first chapter with sixth chapter, geometric progressions chapter. Next, sixth question. If the sum of the zeros is log sum of the zeros of a quadratic polynomial, sum of zeros is equal to what is given? Log 32 to the base 2 plus log 2 to the base 2. Log 32 to the base 2 plus log 2 to the base 2. This is the sum of the zeros. And the difference of zeros is given as log 32 to the base 2 minus log 8 to the base 2. 8 to the base 2. Then what is the question? If they have given, find the quadratic polynomial. Find the quadratic polynomial as these zeros. So third chapter and first chapter connective. As sum of the zeros is given log 32 to the base 2 plus log 2 to the base 2. Here you can do in two methods. Log A plus log B is equal to log AB, or else individually you can solve. Log 32 can be written as log 2 to the power of 5 to the base 2. Like that also you can do. So I will do in first model. Log 32 plus log 2 can be written as log 64 to the base 2. It can be written as log 2 to the power of 6 to the base 2 is equal to 6 log 2 to the base 2 is 6 value. And in the difference is given Log 32 is 5 I am writing, and 3 log 8 to the base 2 as 3 I am writing. This becomes 2. So sum of the zeros means alpha plus beta is equal to 6, and difference of zeros means alpha minus beta. Alpha minus beta is equal to 2 we got. So this can be cancelled by elimination method. 2 alpha, here you got fourth chapter connective also. So connection with the third, fourth and first chapter. 2 alpha is equal to 8 and implies alpha is equal to 4. If alpha is 4, from this equation alpha plus beta is 6. So beta is equal to 2. You will get beta is equal to 2. Six minus 4. Okay. Then alpha betas you got. Alpha is 4. Beta is 2. Then quadratic polynomial with zeros is, what is the formula? K of x square minus k of x square minus alpha plus beta of x plus alpha beta. That is the quadratic polynomial with zeros. So that implies k of x square minus alpha plus beta is 6, 6x plus alpha beta is 4 to the 8, because alpha is 4 and beta is 2. So if k is equal to 1, required polynomial is x square minus 6x plus 8. That is the answer. So sum of zeros is log 32 to the base 2 and log 2 to the base 2. Log 32 to the base 2 plus log 2 to the base 2, 32 to the 64, it becomes to the base 2 is equal to log 2 to the power of 6 to the base 2 is equal to 6 you will get. So this is sum of the zeros. So sum of the zeros is indicated by alpha plus beta is equal to 6 you got. And next this is log 32 to the base 2 is, you can write it as log 2 to the power of 5 to the base 2. So that is 5 minus log 8 can be written as 2 cube. 2 cube to the base 2 is 3. So 5 minus 3 is 2. So alpha minus beta is 2 you got. And beta gets cancelled. 2 alpha is equal to 8. Alpha is equal to 4. And alpha plus beta is equal to 6. That implies beta can be written as 6 minus 4. That is 2. So alpha is 4 and beta is 2. So quadratic polynomial with zeros is k of x square minus alpha plus beta of x plus alpha beta. In that you substitute k is equal to, if k is equal to 1, you can consider x square plus minus 6x plus 8 is the required quadratic polynomial. Required quadratic polynomial. This is a connective question with the first chapter, third chapter and fourth chapter. One more question. If 2 to the power of a into 5 to the power of b is equal to 1000, then find the mean of a comma b. Find the mean of a comma b. So 2 to the power of a into 5 to the power of b is equal to 1000 can be written as 2 square into 5 cube as a prime factorization. Then a is equal to 2 you will get, b is equal to 3 you will get. And what is the mean formula? Sum of observations sigma xi by n if it is a raw data. So sigma xi by n is the formula. Sum of the observations by number of observations. So sum of observations a plus b by number of observations is 2. So 5 by 2 is nothing but 2.5. So this is a connective question with statistics and first chapter. Statistics and first chapter. Next, One more beautiful question you see. If 189 by 7 to the power of a into 3 to the power of b plus 3 into 2 is a terminating decimal, then form a quadratic equation with a comma b as roots. Then form a quadratic equation, here he asked. So fifth chapter connective. Quadratic polynomial previously we wrote, now here quadratic equation with a b as roots. A comma b as roots. Okay, so you have to do the prime factorization of 189. So given condition only I'm taking. So 189 prime factors as 7 into 3 to the power of 3 by, it can be written as, denominator can be written as 7 to the power of a into 3 to the power of b plus 3 into 2. If I will write like this, then what you have to do now, the powers of, you have to get the a value, so you have to equate the powers of 7. So 7 to the power of a is equal to 7 to the power of 1, implies a is equal to 1, you will get a is equal to 1, because you know the terminating decimal means denominator should be in the form of 2 to the power of m into 5 to the power of n form only. Other terms you should not be there. If for denominator also a is 1, then 7 power 1 will become 7 power 7 gets cancelled. Both will get cancelled, and you can get removal of 7 in the denominator. In the same way, you have to see the 3 to the power of b plus 3 can be equated to 3 cube. Then base are equal, power should be equated. 3 b plus 3 is equal to 3, b is equal to 0, you will get 3 minus 3, 0. If b power 0 is there, then it becomes 0 plus 3 is 3 cube, 3 cube gets cancelled, and in the denominator purely 2 is there, and 2 means, that means 2 into 5 to the power of 0 form it will become. So it is a terminating decimal. Okay, so that is the reason we are writing like this. Okay, now what you have to write, a b values as the roots, you have to form a quadratic equation. You have to form a quadratic equation. So what is the quadratic equation with roots? K of, no need to write here K of. So x square minus alpha plus beta of x plus alpha beta is equal to 0. Is equal to 0. Implies x square minus alpha plus beta is a plus b. A plus b is x. 1. A plus b is 1 plus 0 is 1. 1 of x plus alpha into beta is 1 into 0 is nothing but 0. So what is the required quadratic equation? X square minus x is equal to 0. X square minus x is equal to 0 is the required quadratic equation. So this is a connective question with terminating decimals and fifth chapter quadratic equations. So mainly you have to understand that denominator is in the form of 2 to the power of m into 5 to the power of n, then only it is called as terminating decimal. Other values should not be there in the denominator. That's why we cancelled. Next, ninth question. The denominator of 91 by 1250 in the form of 2 to the power of m into 5 to the power of n. Then find the LCM and HCF of m and n. LCM and HCF of m and n. So you have to write 91 by 1250 as a prime factors. 13 into 7 by 1250 can be written as 5 to the power of 4 into 2 to the power of 1, or 2 to the power of 1 into 5 to the power of 4. So denominator you have to equate it to this form. So 2 to the power of 1 into 5 to the power of 4 can be equated to 2 to the power of m into 5 to the power of n. So here m is equal to 1 and n is equal to 4. M is equal to 1 and n is equal to 4. So if m is equal to 1 and n is equal to 4, what he asked LCM and HCF of m and n. So LCM is nothing but least common multiple. So 1 and 4 are co-primes. 1 into 4 is the 4 is LCM. And HCF is highest common factor. They are co-primes. Least number is the 1 is the HCF. Since 1 and 4 are co-primes. Co-primes HCF is 1 and LCM is their product. And LCM is their product. How nice the sums are. No? So how they connected, interconnection, intra-connection, chapter to chapter and concept to concept. Next, 10th question. If log a to the base 2 is the HCF of 125 and 45, is the HCF of 125 and 45, then find the value of a. Then find the value of a. So HCF we can do by Euclid's division lemma. So 45, 125 is divided with 45, it goes 2 times 90, and then 35 is the remainder. Then 45 becomes the dividend 1 time 35, so 10. 10 becomes the divisor and 35 becomes the dividend 3 times 30, 5, 10, 2 times 10, 0. 0 remainder. Whenever 0 remainder comes, whose divisor is the HCF? So HCF is 5. HCF is 5. What according to the given condition? Log a to the base 2 is equal to HCF of those numbers. That is equal to 5 you have to write. And then according to the logarithmic law, a is equal to what you will get? 2 to the power of 5. So a is equal to 32 is the answer. A is equal to 32. Okay. So this is within the chapter only, HCF and logarithms. LCM and HCF and logarithms. Next, 11th question. Solve log of 3 to the power of 2x minus 3 to the power of x plus 1 to the base 3 is equal to x. Then find x value. So again here definition you have to apply. Log n to the base a is equal to x. Then a power x is equal to n. So here you will get 3 power x is equal to 3 to the power of 2x minus 3 power x plus 1. So then I am transposing 3 power x to that side. 0 is equal to 3 power 2x minus 3 power x minus 3 power x plus 1, like terms together. So 3 power 2x minus 2 into 3 power x plus 1 is equal to 0. I am taking 3 power x as a. Let us assume that 3 power x is equal to a. Then the equation becomes a square, because 3 power x can be written as 3 power 2x can be written as 3 power x whole square. 3 power x whole square. So 3 power 2x can be written as 3 power x whole square. So I am writing 3 power 2x as 3 power x whole square. So a square minus 2a plus 1 is equal to 0. Here it is a quadratic equation. Quadratic equation, by solving this, a square you will get. So factors for a square is minus a, and if you add you will get minus 2a. So that it becomes a square minus a plus 1 is equal to 0. So a common, a minus 1, minus a common, minus 1 common, a minus 1 is equal to 0. So a minus 1 of a minus 1 is equal to 0. A is equal to 1 or 1. So a is equal to 1. Equal roots you got. Then find the x value he asked. So what you have to write? What you assumed as a 3 power x. So 3 power x is equal to a. A is what? 1. So 1 can be written as 3 power x is equal to 3 power 0 implies x is equal to 0. So what is the x value? 0 is the x value. X is 0. So logarithms and quadratic equations, connective question. Logarithms and quadratic equations. Next, one more. 12th question. If the HCF of 65 and 117 is expressed as 65m minus 117, then find the value of m. So HCF of 65 and 117 means you have to do the again Euclid's division lemma method. So 65 one time it will go 65, 52 is the remainder, then 65 can be written as one time again it will go 52, 13, 52 is the dividend and 4 times it will go 52, 0. So what is the HCF? Whenever the 0 remainder comes, whose divisor is the HCF? 13 is the HCF. Then what he asked according to the condition, 65m minus 117 is equal to HCF, they said. 117 is equal to HCF. HCF is 13. Then transpose 65m is equal to 120. 13 plus 117, 130, sorry. 130. Next, m is equal to 130 by 65. 65 2s are 130. So m is equal to 2 is the answer. M is equal to 2. Okay. All the best.